you're all more than welcome to New Now Next. This is actually the 10th year that we've been doing this with Arup, which is fantastic. This is probably my 30th or 35th time welcoming people to New Now Next, which is wonderful. And in that time, we have amassed an impressive amount of really great speakers enabled by their partnership. And I really want to thank them. So this is a milestone moment. It's also our first physical event, New Now Next event in 2 years. So we're delighted to welcome you here in the complex. It's a wonderful venue. So just to explain, my name's Natalie Wadig. I'm director of the Irish Architecture Foundation, and we're a not-for-profit agency funded by Arts Council, and we're passionate about creating open platforms to discuss the most essential issues. So this year, in conversations with Arup, we decided to theme this year around activism, and we wanted to explore how architecture is a central force affecting change within, say, the circular economy, spatial equity, and sustainable urban development. So while I have your attention, I just want to also alert you to next week's event with Joss Boyce, same time, same place. So hopefully you can book that, and it's free, and you can book it through our website. So I really recommend that you go to that. So and you can also find out about all our other events on our website. So please check us out. So back to this evening, just to say that we are streaming this live. It is also recorded and for the IF website and our archive. So this is an exciting moment for us to have Maarten here to speak at the IF. And he represents the breadth of environmentally responsible design thinking that is urgently needed today, which is why we've invited him to Dublin. And it's just, for me, it's a great honor. I've been really interested in your work, Maarten, going back to when you curated the Belgian Pavilion in 2010, and that exhibition that you did with your team is one that I keep on talking about to this day when we talk about how to curate exhibitions and curating architecture. Anyway, but first, I'm only here to say hello, so I'll stop. But first, I want to introduce you to Janet Lynch from Arup, who will introduce Maarten, and then Maarten speaks, and then there's a Q&A and a conversation on stage, and we have roving mics, so we're all set up for that. So Janet, it was wonderful to actually meet Janet and encounter Janet, but Janet is Arup Europe Skills Lead for Circular Economy. She has over 20 years experience of circular economy and resource efficiency in the built environment. She started her career working in Dublin City Council and Sustainable Energy Ireland before moving to Arup London in 2006. She is now based in Dublin and leads the global team of specialists delivering circular economy projects for clients. Her projects include the T2 Economy Plan, Crossrail Island, London 2012 Olympics, DART Underground, N6 Galway City Ring Road, and Bus Connects. She is a chartered civil engineer and chair of the National Standards Authority of Ireland's Committee on Circular Economy in the construction sector, and is Ireland's representative on the European equivalent CEN. So before Janet comes to the stage, I want to thank everybody for coming. I want to thank Arup, Owen Lynch, Rory McGowan, and Emer Lynch, Andrew Griffin as well for his special help, and also to the IF team, Vanessa, Felicity, Alba, and enjoy this evening's talk. Thanks very much.
Thanks so much, Natalie. I'm here this evening to introduce our speaker, Maarten Gielen. And we're absolutely delighted to welcome Maarten to the first of the New Now Next talks for 2022. And Maarten is the Managing Director of Rotor DC. This is the part of Rotor responsible for the reuse of building materials. Maarten is an award-winning Brussels-based designer and researcher, a leading practitioner in changing the way materials are used in architecture, construction, and engineering. Maarten co-founded the collective Rotor in 2006. It's a collaborative practice. It investigates organisation of the built environment to help designers and architects salvage building materials, reduce waste, and create a circular economy. Rotor shares its insights and its projects through publications, exhibitions, and events like this evening's talk. Maarten is known as the curator of the fantastic OMA exhibition in the Barbican with Rem Koolhaus that Natalie mentioned, the 2008 Belgian Pavilion at the Venice Biennale, and as the curator of the Oslo Triennale in 2012. Rotor, since its foundation over a decade ago, now employs dozens of staff to share the process and implement the process of materials reuse in our industry, the built and the natural environment. This is not an easy undertaking. It's a complex system with many stakeholders. So I'm delighted to have Maarten here this evening in his leading light in this field, and please join me in welcoming Maarten to share his journey in the reuse of materials throughout Europe.
Thank you, Janet and Natalie, for such flattering introduction. I've been asked, for the ones that are following this event through text, to sort of describe myself, which is a very difficult exercise. I would say I'm about average height, 37 years old. I'm wearing white glasses, and I'm trying to conceal a little belly. When we talk about architecture, most of the time we talk about the result of a process of accumulation. A building is seemingly constructed out of thin air. Materials are assembled around it. Like, for instance, this CCTV building in Beijing by the office OMA that is wonderfully clad with Middle Eastern natural stone. At Rotor, what sets us apart, I think, of other practices is that we consider both the process of accumulation and the process of subtraction that usually takes place in places around. In a single act of architecture, in a single design, we add materials on one side of the world and we subtract them in another. And so I would like to argue, for starters, that a quarry is as much a product of architecture, perhaps even more so than a building. At least the quarry is much more permanent. And under the influences of, let's say, sustainability first, and then energy efficiency and sort of the evolutions that we've seen in architecture over the past 3, 4, 5 decades, I would say the first 2/3 of that evolution, materiality, has been largely ignored to the benefit of talks about energy efficiency, right? We're adding more glass, we're adding more frames, we're adding bigger envelopes, heavier structures to support all that. And the materials rarely come up in the CO2 balance sheets. I think that's slightly changing in the last 5 years. But sustainability in architecture is still very much a question about how much rock wool can you add to a facade. When we look at the city of Brussels, which is where we are based, you have about 1.1 million inhabitants that produce 650,000 tons of C&D waste. And these are really very optimistic numbers that are a few years old. I would say that we're probably closer to a million. What is also clear is that we are adding more materials than what we are subtracting. So there's a densification process. There's more materials being added. Cities grow fatter in a way. And we typically, as architects, when we started 15 years ago, actually we know very little about what happens with these materials. They sort of disappear in a skip. They arrive in neat pallets. and where they come from, what they go, where they go to afterwards is sort of outside of the realm of architecture theory. Now, I think before we start talking about these processes of material addition and subtraction, I think it's interesting to just have a moment to think about the conceptual reason for these things. Like, why are cities actually changing and renovating and demolishing one thing and adding another thing all the time? And you could say, and it's an exercise that I like doing with students at the beginning of the year, is just to sort of take a few newsprint articles and then try to imagine what the material consequence of that article is. For instance, here, as you might know, we had some terrorist attacks in the airport a few years ago. The military sort of took over a lot of the public space, and so you had shelters and antennas and all kinds of new equipment being in public space. And then a political decision is taken that the threat level, which is an assessment made by an abstract committee of experts, I would say, so that threat level goes from 3 to 2. It's a very abstract thing. Well, immediately after, it means that the army is selling off bunches of unneeded shelters, equipment that they no longer need, and so on. And so what you see is that there is a sort of a constant adaptation of the world of the ideas on the world of the materials, and it works in both sense, but every time an idea changes, the material world sort of has to follow. Another example, WeWork, you might be familiar with the documentary We Crush, which was released on Apple TV a few months ago, I would say by now. The idea of WeWork was, as a company, they would rent vast quantities of office space, make them very fancy with super good Wi-Fi and furniture and so on, and then rent them out as individual desks to startup-like companies. So, of course, then the quarantine happened, a lot less demand for these sort of flex desk things, and the whole company had to downsize their operation. And so at the moment, there's a big flood of, let's say, mid-range designer furniture on the market, because just thousands of square meters of hay-equipped office spaces are being written off in a very, very short period of time. So when we talk about these flows of materials, I think in terms of terminology, we need to distinguish two sort of approaches. I mean, there's a lot of things that happen to these materials. Some get burned, some get landfilled, and some are treated in an eco-responsible way, right? And within that eco-responsible way, there's two approaches that are predominant and that I would like to distinguish. On the left side, you have what we call reuse, hergebruik in Dutch, sorry for that. What you're seeing is a couple of workers that are demounting marble slabs, a cladding from an interior cladding from an office building, actually a railroad station. They are being neatly stacked on pallets, and they are fit for reuse as a floor, or maybe a bathroom cladding, or maybe another sort of corporate space. On the right, what you see is a process of recycling, where quite similar materials are being taken down with a crane, crushed. They go, in this case, through, there's a bit of reverb on this. Yeah. They go through a sorting line, so you have stationary people who sort of see that trash come by all day, and they remove the plastic and the metal and so on from that thing. So in terms of the kind of jobs that it creates, in terms of the kind of materials that it makes available, on the one side you have marble slabs, on the other one you have crushed stone. So we are interested in this practice of reuse. Just to give a very concrete example of how that goes, a 17-year-old building that was leased by the Flemish government, at the end of the lease, the building is, well, very difficult to repurpose for another. Not so many people have a need for a parliament, so at the end of that lease, that gets demolished, right? we intervene, we make a sort of a catalog of parts that we find interesting, we demount them, we find new uses for them just a few kilometers away, depending on what road you take. And that may seem like a very straightforward and simple thing, but it's not, because it's basically not happening most of the time. So the rest of the lecture, we're going to have a look at what would it take for reclaimed materials to be as easy to reuse as ordering new materials. That is sort of the horizon. That's the idea that we have been working on the last 10 years. So, of course, we are interested in very clever pilot schemes where impossible things are done to reuse certain building materials with clients that have unlimited budgets, architects that have unlimited time, and so on. But what we're really interested in is how to mainstream this practice. What would it take in terms of architecture, in terms of infrastructure? And what we have in front of us is a sort of a chicken or the egg situation, like what comes first, the chicken or the egg? So you see here an image of a building that is clad in different types of steel profiled cladding. This is actually a project that was won by a few architects for, well, the program is a sort of an incubator for circular economy companies in Brussels. And during the competition phase, of course, reuse, recycling, and so on were absolutely given some attention. And the architects proposed to make a facade out of salvaged steel cladding. So the idea was, we will find some buildings that are being demolished, we will take that cladding and use that cladding to cover up the insulation of the building that we are renovating or building new. I'm sorry, I'm not sure about that. Now, when they win the competition with this idea, then we go a year forward, and the contractor needs to find salvaged steel cladding. And the problem, of course, is there are no suppliers of salvaged steel cladding in Brussels. Actually, it's a very cheap material to buy new. It's a very labor-intensive material to demount. You don't get warranty on something that is exterior. That is not a light problem, like how is it going to look in 10 years from now. And so the project sort of, I mean, they recycled the look of the building. I'm sorry, I had to sneeze. They recycled the visual aspect of the building using multiple types and multiple colors of that material, but they were not able to reuse material in that context because supply was not there. I could have given another example where people try to organize demand for something. Sorry, where they take a material into stock, and after a few years, they have to realize that there is no demand for that, and so that the story ends there. Now, reuse also opens up a lot of other questions which have to do with all the nitty-gritty things. Like, for instance, what you see here on this picture is a small hangar, a small building in detached parts. So you have the cladding, the structure, the bolts on top. Now, imagine as an architect that you have a client that wants exactly this building. Actually, he or she needs a garage next door, and this is the exact right dimensions. Like, at what point do you buy this building? Are you going to buy it before having a building permit, hoping that you'll get the building permit and that the city will not say, we would like a slightly more transparent, or we would like the height of that building to be in relationship to the height of the building of the neighbor, or whatever might come up. You're taking a risk if you buy too early. On the other hand, are you really going to write a building application on one specific material, knowing that actually by the time you get the permit, the building might no longer be for sale and there's no second one next to it. Now, the whole thing becomes more complicated when you think that perhaps you want only half of the building, so you want the structure to be recalculated, or you want it to be slightly higher. You maybe want it in a different color, you maybe want it with some form of warranty, and so on and so on. So, not an easy thing to do. I mean, we could just all go out and buy a second-hand building and put it in our garden. As long as the neighbors don't complain, fine, you know. But on a professional level, as architects, these are not easy things to do, because in a way, another OMA project that I'm showing here, the recently opened Taipei Performing Arts Center, and you're seeing a junior architect sort of clicking through a CAD drawing. Architects, what they produce is drawings, is specifications, is text, is paper, right? Architects typically don't touch the materials that go in their buildings. Architects work with instructions, with abstract versions of the materials that they that they prescribe. It's the contractors who do the translation of those specifications into a material reality. So what we need is a sort of a perfect storm where this supply and demand magically coexists at the same time. And so that's basically been our project in Brussels for the last 10 to 15 years. To kind of make that happen. What needs to happen first? What can we already put in place, and so on. And so I'm going to run through a few ideas, a few conclusions that I think are also relevant for other cities. Now, the first thing we advise everybody to do when starting to be interested in this subject is have a look at what already exists. Like in most territories, there's already going to be a number of dealers in second-hand building materials. These are typically in the countryside. They're specialized in sort of one thing or another, and for some reason, they managed to keep their business thrive. Like reuse is not a new thing. It's as old as buildings, probably, but it's after the Second World War, it sort of has disappeared. And now it's something that still exists in the niche. So our suggestion is make a sort of a thorough mapping of what exists in the niche, and then you can start building on top of that. Like you basically find the eggs, and so you don't have that first problem to solve. So in Belgium, we found about 100 companies. This might be a demolition contractor that keeps some second-hand steel on the side for small projects, or the very well-organized brick cleaning industry. And so the business of these people is to take a heterogeneous stream of materials. For instance, a brick, a few containers of brick coming from a demolition of a building, to clean them, to condition them in such a way that they can be used by architects. Like this is how architects, or how the construction industry at large treats materials. Imagine the surprise on your contractor's face if you deliver a dump truck of these bricks on site and say, well, I would like you to make a wall with this. That's not how it works, as I'm sure you all agree. And you might think that what happens here is like a very almost technical approach, just cleaning the bricks, stacking them, palletizing them, but also a lot of expertise goes in there. Like for instance, this type of brick that I'm showing you now comes from pre-industrial ovens, and so it means that the outsides were much colder than the insides. The coal is basically mixed in, or is stacked in between the bricks when the oven is lit. So you'll have overbaked bricks and you'll have underbaked bricks. And the overbaked bricks, they're quite brittle, but they are super water resistant. So for a facade cladding, they are quite ideal. Now the underbaked bricks, they are not glazed, so they tend to absorb a lot of water, but they are slightly more flexible. You can abuse of them in an easier way. So for some applications that might be relevant. And also you can use them for interior partitions or things like that. Now, when you take down, I mean, this means that any building built in these bricks that is still standing today, the people, the masons that worked on those buildings, they knew how to distinguish these bricks, right? These were not CE marked standardized building materials. You needed some skill to recognize a brick at that moment. But when we demolish all these bricks and we bring them together and we scoop them up and we bring them to a sorting facility, of course they're all mixed, and so another form of sorting needs to happen. You also don't want bricks to be reused that were part of chimneys, for instance, and so on. So there's a grading process. Now, the current salvaged materials industry, you will not find the equivalent of CE markings for most products, and a lot of the services that you kind of expect for new products won't be there. However, when you work with established dealers, you can rely on their know-how, you can get some advice, you get some form of quality control. Now, it's not only the private industry, of course, that is interesting in this case. What I'm showing you here is a stack of cobblestones owned by the city of Paris. So the city of Paris has a central warehouse where every time that a square or a street is being opened up, all of the natural stone is transported to this central warehouse. Typical contract with any demolition contractor working in public space in Paris will say the materials, we know how much materials there were, and you need to bring 95% of them to our warehouse, or you get penalties. And there they are being processed and prepared for reuse. So this central warehouse means that the city sort of considers, well, I'm going to use a very popular image in our industry, but sort of considers this as a collection of Lego blocks. So what was that square at one point is sort of being transported, centrally stored, and reused at a different scale. This is like a 16,000 tons a year, so it's a huge operation. It also I think it shapes sort of the identity of a city if you start working on this scale of reuse and actually material continuity. So we started mapping these facilities, like who has operational capacity to deal with secondhand building materials, and we made a website called Opalis. Now Opalis started with just Brussels, where there's not that much. Then we started working on the whole of Belgium. 4 years ago, we got an Interreg project from the European Union. It was actually the last Interreg project where the UK was still considered part of European territory. So we quickly did the last mapping we could do with European money on UK soil. So this database is growing. We're at 500-600 companies in the territory that you see there. The Netherlands has been mapped, France, the UK, Belgium, and right now with students at KIT in Karlsruhe, we are mapping the German context as well. To give you an idea, this is about 100 companies that my students found in just 2 weeks. So I'm pretty sure that a similar exercise in Ireland would absolutely make sense. It's not that time consuming. What is time consuming is to sort of document these cases then and make a guide or trying to understand what it all means. Now, a second point in the work that we're doing is that for as I said, architects, they work with paper. So you need a sort of a digital twin or a paper twin for every material that is going to be reused. So, for instance, why are boardwalk stones in blue limestone, actually the same blue limestone, geologically speaking, as the one you have here in Ireland? It's the same material that pops up in two different spaces. So why are our Belgian blue limestone boardwalk edges being replaced by bluish sandstone from Vietnam? And when you look at the standard specification sheets that are being copy-pasted by public commissioners and architects for generations sometimes, you can trace them back to the 1950s. And one of the weird things in this document that has proliferated in Belgium is that there is a requirement that within a given project, all of the boardwalk stones need to have the same length. Now, I don't know any landscape designers or architects that sort of have an obsession with the exact length of the stones that line the boardwalks. And actually, it's not a design requirement. It was something that was sort of sneaked into these requirements by the Natural Stone Lobby in the 50s, when the quarries after the Second World War wanted to make sure that they had a sort of a stable volume, because it is very hard when you salvage these materials from different streets, from different locations, to sort of guarantee that they all have the exact same length. Now, what we did, it was a project in which we, for a number of materials that are commonly traded second-hand, but where we noticed that professional clients were almost not using these materials, was to write standardized specification sheets. And so we had to do the exercise, why is there this requirement of length? Does it have to do with how these materials are being craned, installed, and so on? We brought together contractors, we brought together traders, and it turned out to be absolutely not necessary. So we made our own alternative specification sheet that we promoted in Brussels. And so this sort of like, just, you know, is this even design or architecture? Just changing the way you describe the material, the required material is enabling reuse on a scale that should be able to compete with Paris, right? Why can it happen in Paris and not in Brussels? Well, because of a few stupid specifications that were hanging around. And the legal framework and how to deal with that is another key issue. What we see is that actually, you know, most architects or even I mean, working in the public sector, inspecting building permits or commissioning demolition or design works, they are not legal counselors, right? They work with a sort of a general idea of what is possible within the law that has been established to their professional practice. A lot more than what we actually use is possible in the law. Like, for instance, when you're tendering in public, the general idea is basically that it needs to be fair, but you can open up and you can accomplish that fairness in many different ways. Let me give you an example from a design perspective. Like I explained how difficult it is to acquire the materials, or how dangerous it is to require the materials before you are asking for a building permit. So what you're seeing here is a facade with 5 windows, maybe six windows. They all have a different color. They're all made in a different material. They all have a different shape. And this is because these are wrongly ordered windows from a window manufacturer. In order to reuse this material, what we did is we submitted to the city a building permit in which the size of the windows was marked in dotted lines. So we did not promise to a specific design for the facade. We basically said, like, the biggest window will be on the left and will be centered on that, and it will be between that size and that size. And then you have the one in the top, which will be between that size and that size. And so we made a sort of a drawing that allowed us, once we got the building permit, to go to one of the informal resellers of these types of wrongly produced windows and buy whatever we found. And as you can see, the window on the bottom left is an arched window, which we even mounted upside down because it was within the within the limits of the minimum or maximum surface that we promised. It takes a lot of courage of a city council to sort of allow these things, but it is perfectly legal. You know, the requirement for a building permit is that it should be tangible what the project is and how it's going to affect the neighbors. If you are showing that there is no direct vis-a-vis, that if you answer a sort of a series of questions, then these sort of projects are absolutely possible. And even in a design competition, here I'm showing you a project that we did with 51N4E. It was another public commission, regional authorities, waste management authorities wanted a small sorting plant for municipal waste. It's going to be a place where people can sort of drop off their old fridge and they will go into different containers depending on what needs to happen with them. When this commission was launched, when this competition was opened up, we started playing around with the program, and we realized actually that it was quite a generic program. Like, it doesn't really matter whether this building is 39 by 27 or 35 by, I don't know, you know, it's basically a big structure under which trucks can circulate with no structure in the middle, and it could be a steel portal frame, it could be a laminated wood one, and so on. And we found this other building about 70 kilometers away from Brussels in the city of Liège, and this building was standing in the area where a runway for the Liège airport was going to be extended. So we knew that within the next 5 years it needed to come down, and so we proposed to move a building from one site to another. We were basically telling our clients, your requirements are pretty generic. We can basically get any kind of building that fits these sort of requirements. And we even showed, instead of making one plan for the competition, we showed 4 different structures that were available for purchase at that moment, and any of the 4 would have suited. Of course, the sort of the marvelous glulam 1970s structure was our favorite to start with, and we're very happy that this project is being realized. So a lot of the things that we do at Rotor are sort of very boring, very basic, and they just need a lot of perseverance. Like, for instance, we did an alternative manual for commissioning demolition projects by public governments. So there's 2 requirements typically in a demolition project of any scale. Is how much is it going to cost and how fast can you do? And that basically, those are the 2 requirements that you can find in any tender for demolition works. Now, of course, you can use other criteria. You can ask for contractors to treat those materials in a particular way. You can ask for limits to sort of noise and machinery use on site. You can ask everything you want, as long as it is fair, as long as it's clear to everybody that is going to submit a proposal. You can basically ask what you want. Like, for instance, 50 years ago, buildings were still being sold for demolition. So it was understood that the value of a building was higher than the cost for demolishing it. And you can still do that, and sometimes it might even work, like in the case of that Liège, that manège in Liège. Sorry, that's a strange rhyme. Actually, that building has a net positive value, probably, but if you are going to do a competition like that, time is going to be of the essence. So you can probably not do that in the busiest streets of London. You can also probably not do that with any kind of building typology, but it is still a possibility. And so what we made is these yellow sheets that we're very proud of. We worked with an external legal counsel that assured us, like, if all of these questions are filled in correctly, and if this is the tender for demolition that is being published, it is perfectly legal. It will withstand any sort of scrutiny. And then we come to the sort of the most exciting part, I think, of our work, which is that you cannot run a circular economy on consultants only. And I think right now the circular economy is like 3 consultants for every operator. With that I mean that there is really a lack of capacity in our industry, in the salvage industry, to deal with bigger demands of materials, with bigger offers of materials. And so what we are seeing is a lot of companies, a lot of startups, they are focusing on the service that you can provide to an owner, of making a building inventory, of making an assessment of whether steel beams are still sound, and so on and so on. But what we're really lacking is an operational capacity to then, when we decide that those beams are sound, that that building can move, who's actually going to be the contractor doing it, or who is going to acquire those materials, keep them for the time that is needed, and offer them for sale so that architects can use them in the building. And from my point of view, that is really the bottleneck. And once this thing gets flowing, then you actually and this is a joke that we have. It's like the circular economy. Once we sort of get it running at a scale that is sufficiently high, you probably won't need that many consultants. In the same way that when you order a glue lamp structure, a lot of the services, a lot of the testing will be done by your supplier. When we go to the next phase in the circular economy, you will also not need sort of an independent assessment of those materials if your provider can guarantee it. Now, we are a long way from that point, because when we look at the typical dealer in second-hand building materials, I mean, there's 100 in Belgium, and I'm showing you nice cobblestones and steel and so on. Many of them are basically building antique stores. So if you have a blue limestone lion in the front of a castle, that will probably be of interest to them. If you have like a semi-solid wood parquet floor that is barely 5 years old, they will probably snub it, because they will say like, oof, our clients are only interested in at least pre-Second World War materials. And so there is a mismatch between the industry as it exists today and the sort of buildings that are being demolished or renovated. And in Brussels, this is particularly clear, because a lot of the things that are being demolished is office spaces. Now, I don't know how the market is here in Ireland, but in Brussels, office spaces are rented out rough, meaning that the life expectancies of an interior is basically the duration of that the rent will be there. After every lease, buildings are being returned to the bare concrete, the bare structure, all the lights, the walls, and so on will be removed. And so when you Google like reuse of building materials, you'll probably find a lot of projects using pallet wood or sort of old barn wood and so on. But the reality is that the materials that are being discarded come mostly from corporate spaces, from service spaces and so on. So you have a sort of a hierarchy on the top. You have bars, restaurants, they change like every 3 or 5 years. Then you have retail, maybe 5 to 6 years. Then you have office spaces. Then you have hospitals. And maybe all the way in down, you have basically public spaces, like administrative building of public. And then all the way down, really, really towards the end, you have social housing, which after it's built, you can sort of be happy if it's even properly maintained. So they're certainly not being renovated thoroughly. Now, this is for Belgium. I do not wish to offend any of you that might be involved in social housing in Ireland. Now, we were consultants once, I have to admit, and probably we still are, but at one point we were challenged by one of our clients who said, here's the key to one of our buildings, 30,000 square meters. You say we need to manage this demolition in a more responsible way. Go for it, like make it happen. You have a few months where nothing is going to happen in that building. Show us what you can do. What we did is we started with an inventory of all the materials in the building. We calculated prices for demounting all of those materials. We had a sort of an idea of what it would cost to demount a wooden frame door and so on and so on. And we started selling them straight from the building. Like the building was our workshop, was our warehouse, was basically our shop front or our showroom, if you like. And so we knew that we had a few months, so getting the information out as quickly as possible, sending it out to as many people as possible, and then just sell whatever we could. And the lesson learned from this exercise is that there is a big difference between what is demountable from a technical point of view and what is reusable. Reusable is a multi-criteria thing. Like, it needs to work from an economical point of view. You cannot sell under price for too long. It needs to be technically relevant. Like, for instance, a lot of the sinks that we had till the 50s, they have two taps, one for cold water, one for warm water. Very few people today want that. Most people will want a mixing tap in the middle. So it means that the market for these old sinks is a pretty difficult one. Now, imagine that this bathroom that I'm showing you, a 70s bathroom, is on the 9th floor of a building in which the elevators no longer work. That's a different kind of case than if it's on the ground floor of a villa with lots of parking space around it. So logistics, how am I going to get these materials out, is actually a determining factor in many cases. And then there is the question of toxicity. I'm challenging you in the room, all of those who don't know this example from a previous lecture, because I have said this in public before. There is one really toxic material in this image. Can you find it? It's not asbestos. You can actually see it. It's quite prominent even. So what we're looking at is a tiled bathroom from the 70s. It's not the mercury on the mirror, no. So the green tiles in the middle, how they got that green is by using a slightly radioactive substance. Now, it doesn't mean that you'll die from brushing your teeth, but it also means that it's probably not the nicest material to put on the market again. So a lot of what circulates in the built environment is slightly or heavily toxic. Like, it's quite scary when you get a demolition assessment of a building and you see how much toxic stuff is in the carpets, in the fire retardant curtains, and so on. Like, all of that is no problem as long as it's a product. The moment that we consider it a waste stream, all of a sudden it becomes super dangerous. And so that bears the question, like, should we consider these products in the first place? Now, as a summary for this whole complex situation, we use this definition, and this is an operational definition, right? This is not a definition that that you can use on a theoretical or an academic version. Basically, what this definition says is the cost of dismantling and processing multiplied by a risk factor. That total needs to be lower than the market value. Basically, it says you need to buy cheaper than what you can sell. And that risk factor can be, the logistics are unpredictable. 20% of your materials might be unsellable because you didn't know people stop using urinals, which is actually a true thing, but that would take us too long. All of these factors, you need to sort of run a little bit of profit on most elements so that you can correct your mistakes. So for us, this is like gravity. We can sort of jump away from it, escape from it for moments, but it's the thing that we always keep coming back to, because we are maybe an activistic company, but at the end we still need to make sure not to go bankrupt in order to remain activistic. Now, the worst materials are the ones that unfortunately have the heaviest impact. Steel and concrete are really, really cheap. Like a cubic meter of concrete in Belgium, now there's this whole thing about it becoming impossibly expensive because of the energy crisis. Actually, a cubic meter of concrete delivered on site costs 112 euros today. So that means that a cubic meter of mineral water is actually more expensive than a cubic meter of concrete. It's incredibly cheap material that is overused for that reason. So we have this test, sort of a thing that we're proposing to do in multiple territories. Like, imagine you hire a worker and you give him or her a full day to pick up concrete pavers from a street. No mortar has been used, there's no complications. They are virtually unchanged after 20 years of use. You just need to pick them up and stack them. Now, the cost of stacking these concrete pavers in Belgium would be 3 times as high as the cost of getting new pavers delivered. You cannot compete with concrete in second hand. And the problem with concrete and steel is that if you are going to build anything you build, the reference prices will always be those of concrete and steel. Like, you're building a cross-laminated building, let's compare it to what it would cost in concrete. That's like the standard practice when you need to convince a client, and that's also the standard practice when we propose second-hand building materials. So as I said, we like to think of ourselves as slightly radical, but we cannot really escape from that. So my job on a daily basis is to go into buildings that are scheduled for demolition and sort of find the materials that are the unicorns, the exceptional materials, the sort of the niche things that you can extract from a building today at a cost that is lower than their market value. And then at one point we were proposed a building from the 1970s, the headquarters of General de Banque, built with lots of money in the 1970s, just before the oil crisis. For instance, on this picture you're seeing a staircase, a double staircase in Wenge wood. I think if today you would extract that amount of Wenge wood from Congo, it would probably be classified as a war crime. It's just an incredible amount of a very, very noble material. Now, as I was saying in my previous deconstruction site, we were selling these things sort of at the back of the building at cheap prices. You're paying close to cost price. When you have a material like this, it's not something that you want to let go. You basically, you can let it go immediately, but then somebody will have to store it for some time, and somebody else needs to design a house around this staircase, because it's not something that you will have by accident the space for. So this particular deconstruction site for us was a very important lesson. Like, all of the red dots that you see on this plan of, so it's about 40,000 square meter building. All of the red dots are applications of asbestos. So as you can imagine, it's never complete. You always find asbestos if you demount things in buildings from the 70s, meaning that we had to train our staff to responsibly react to these situations. What do you do if you find something that you might suspect is asbestos? We had to sort of put in place policies of how you store things in demolition sites. Like on this 3 images ago, next to the Wenge staircase, you have a few hundred square meters of granite, thick granite slabs used as flooring. If you bring these, I think it was about 40 tons of granite slabs, if you put them all in one room, the room might just collapse, right? You need to be able to understand structural diagrams. Actually, there goes as much planning in a deconstruction site, or let's say half of the planning in a deconstruction site as in a building site. A lot of the things require architectural or engineering attention. Like, this building was quite crazy. On the -3 floor, there was actually, we went up, the building went to -6, and on the -3 floor, there was a subway tube going through the building. So you imagine if you need a fire permit for cutting anything that you might need to cut in that building. If you set off a smoke alarm and you close down the subway traffic for half an hour, imagine that cost as compared to those few hundred square meters of granite tiles that justified it. You really need to know what you're doing. Now, the good thing is once you've done the worst, the other ones sort of become much easier. So now this is a routine thing. Buildings, we have one team going into a new building roughly every week. We salvage materials from that, like on these images you see partition walls being demounted. Most partition walls actually they're fairly modular. They're industrially pre-produced, and most industrially produced materials they are fairly standardized. You'll have a few pieces in every floor that sort of fill up the last gap and so on, but you have a certain rhythm in these materials, and so they make good candidates for reuse. Now we have a store with about well, we're on about 4,000 square meters of space filled till the brim with building materials. One of the things, for instance, that we found was really a good service to our fellow citizens of Brussels was to provide what we call a door library. In every period of the city, every area of development, a typical door will have been used with very typical sizes, like they might vary a little bit, but a door in Schaerbeek from the 1950s used in that sort of generation of social housing. There will be like 5, 6, 7 buildings on that. A typical bourgeois 19th century house will have a triple door in separating what we call the trois pièces en enfilade, so a succession of 3 rooms. Those doors are kind of standard or recognizable in any case. And so buildings get transformed all of the time. Some people remove doors, join 2 rooms together, other ones want to split up doors. So having a sort of a central collection of those doors is really a great service it's often the first product. People come to us sort of like the product that makes them decide to start reusing building materials, because many of these doors are very hard to produce new today or will be really costly. We have to find ways to sell certain materials. Like for instance, in this image, in some buildings, actually the hardware is incredibly expensive compared to the rest of the building materials being used. It's sort of the low-hanging fruit of our business. Like imagine if you have 1 metric ton of little how do you call them? The things to open cupboard handles, or you have like a ton of those. Probably that's worth retail something like 12,000 euros or something, like between 10 and 15,000 euros. Imagine having 1 ton of structural steel. What's that going to be? A few hundred euros, probably, maybe 1,000. Like imagine that 1 ton of structural steel breaking down. How much risk it goes in there? Now, if your cabinet handle breaks down, it's like you buy a new one, you complain. That's the worst thing that can happen. And so remember that definition that I gave of what constitutes a reusable material. What you're basically looking for is something that is high value and low risk. And so the steel beam has low risk and high value. The cabinet handle has basically high value, low risk. So we need to find ways to sell these. We decided that we're going to mimic in many ways how the secondhand, well, with the secondhand products, we mimic the way new products are being sold. So we put them underneath a plastic blister with a nice little logo and a cardboard on top of them. Why? Well, when you have a secondhand door handle and you give it to your contractor in this way, they might not even notice that it's that it's secondhand. You know, it's what they expect a delivery of a material to look like. Now, if we would put it in brown paper or a reused cardboard box from the market, they're like, oh, it's going to miss screws. It's just in the psychology of selling things. This is so much easier, and I realized it's not entirely waste-free, but that polyethylene film, the impact of that is really negligible compared to the impact of the casting of these or milling of these stainless steel door handles. So it's of course not only packaging that we do. The problem with tiles, for instance, is how to how to remove mortar from them. So what you're seeing here is a video of a prototype machine that we're building with an with an Italian company right now to basically cut off the mortar of salvage tiles in a sort of a very efficient way. I mean, you think about it and you think like, okay, this is easy. Let's buy 5 and put them in 5 different cities. Like, you do not imagine how much work it is to come to this point. Like, this is 4 or 5 years of R&D to do something that is as simple as that, because the type of blade that you're going to use is going to affect the tolerances in thickness. Now, if you're using traditional mortar bed mounting, like where you put mortar and then you tap the tile until it is flush with the tile next door, you basically almost don't even need to remove the old mortar on top of it. You can integrate any kind of thing. Now, if you want to use tile glue, you basically have a tolerance of a millimeter and a half that you can do. So if you're using a large blade and that blade has a tendency of bending slightly around the material, then all of the tiles actually cannot be used in that way. So it's all super simple until it's not. We remill structural wood, glulam, and cross-laminated timber. Why? Because we cannot win enough competitions for moving buildings. So some of the wood actually is there in demolition projects. Now, storing this in optimal conditions would quickly be more expensive than buying them new. So, however, if we mill them in table slabs, in slabs of 4 or 5 centimeters, that they can be used for kitchens and tables and lofts and I don't know, kind of decorative applications, then all of a sudden we are quite good in the value that we create. We have a lot of fun. What you see here is a shelf that is water cut out of terrazzo slabs. When we demount materials, you always are going to have broken pieces or tiles that were cut because the room ended at one point. There is no market for broken pieces, so we can either throw them away or do sort of nice little design projects with them. That's the fun part of our job. We have an Instagram page because we try to sort of enthusiasm, like for us, the trick of getting architects and designers interested in salvaged materials is really seduction. We can offer you materials that are actually much nicer than anything that you'll find at your trade show, where everything looks the same anyway. And so this is our warehouse with our logo. Now, this is now going to solve all of the issues that the construction industry has. Like the first thing we need to do is to demolish less, and I think that there's a risk of reuse practices being used as a sort of an excuse for demolishing buildings that actually should not. Structural reuse on site is actually the most important focus that we should have in most projects. To give you an example, as a design consultancy, we refuse flat out any demolition reconstruction projects. We just don't do them anymore because we know that we're sort of adding little numbers in the margin, whereas the main savings are on the concrete and steel structure that is in place. And very rarely are there good reasons to demolish these. Now, I want to end with an open invitation because this is a very exciting moment for us. In a few months, we are moving to a new location, much bigger, much better. We have always said of our current facilities that they were sort of a one-to-one scale model of what we would actually be. And we see this new project as the beginning of sort of a narrative where we actually are what we want to be and no longer sort of cardboard pretend this thing. So it's a fascinating building. a relatively small building of 6,000 square meters sitting on a 14,000 square meter plot of land, and that was scheduled for demolition. Why is it scheduled for demolition? Well, because it's sort of an office park in the outskirts of Brussels, and the office are actually all coming downtown now. People want to work close to stations. Car dependency is a big thing, and job attractivity in working in such a place is apparently not so good. So it was scheduled for demolition. We approached the public landowner that wanted to demolish this thing. So typically what they do is they demolish these buildings and then they build sort of 2 rows of boxes for small, medium enterprises. So typical use would be, let's say, a roofer who needs a storage just outside of the city to have deliveries of rock wool or tiles being made there, and then have a sort of a central dispatch to all of the sites in the city. Now, the fact that this building was scheduled for demolition allowed us to say, we offer you to buy the building for €1, and they accepted. However, we also have a lease on the land, so we acquired the building. The entire building is basically a reuse project at this moment, the biggest salvage that we've ever made, and we don't even have to move it. However, of course, we pay a 30-year sort of normal tariff rate, normal rate lease on the land. So every square meter of that land is to generate, in our case, about 13, 14 euros a square meter times the 14,000 square meters that we'll be occupying. But we have this building in the middle of it, and so the project is going to be a weird form of densification of that existing building. So we have loading docks that we can reuse. We can even reuse the slogan of the previous company that was in there. The slogan on the wall reads, a world of reliable rotation. The previous tenant was SKF. Roll bearing, is that the word? Like they make the little balls that make things smoother in turning around. So that's a happy coincidence. And a lot of the spaces there look exactly like the spaces that we work in, so we're used to this kind of materiality, and we think it's actually quite funny to save one, you know. For once, we're not there to sort of pick the best pieces out of it, but to try and make sense of the ensemble. And the idea is to use this 80s infrastructure and to enhance it with any buildings that we get commissioned to deconstruct and that we consider as donors. I already mentioned the WeWork spaces that are going out of use these days. So we recently worked in a 6,000. I mean, we are renting a 6,000 to be renovated. A 6,000 square meter to be renovated building, and we get offered a brand new 3-year-old WeWork high standards building. And so all of the lights that you see in this image are going into our new project. I think we are the only architecture firm that actually got whose Wi-Fi got financed by Goldman Sachs. So that's kind of like, I mean, the open invitation is that you're all very welcome in Brussels to come enjoy what will probably be the best Wi-Fi in town. We have a tremendous amount of infrastructure that we're getting out of these buildings, and so we will use them to equip ours. Like for the anecdote, we even managed to salvage at the entrance of this WeWork, there was a huge library full of books that nobody ever opened. A single copy of every book Phaidon currently has on sale. So you're almost more than welcome to join us in Brussels in a couple of months when we open this new building, and you can pick the Oliver Lyson retrospective collection to go along with that coffee. Thank you very much.
Hi, can you hear me? Okay, super. Okay, thanks so much, Martin. That was such an inspiring talk. It's absolutely wonderful. So we're going to have a Q&A session now. So there's a roving mic here in the audience. Now the lights are quite bright, so I just ask you to raise your hand so the roving mic can see you. And so if there's any, the questions for Martin, so if you could introduce yourself, please, before you ask a question. And then if you're from an organization, we'd welcome if you'd also say what organization you're attending from. So would anyone like to open the floor? I see there's a gentleman there. I think there'll just be a microphone with you now, just one moment. Thanks.
So you do a lot of work with reusing existing materials that are obviously really, really hard to use because they weren't designed that way in the first place. And obviously reuse is focused on designing new materials that we can use in pilot so that we can make it easier.
It's a very important question, of course, like how do we design for deconstruction, basically, and there's a lot that has been done on a theoretical level on that. Like if you Google the phrase design for deconstruction, you'll find general guidelines. For instance, it's much easier to salvage a part that can be lifted by 2 human beings, so meaning underneath 65 kilograms, than designing bigger elements. I mean, there's different schools in that, because some people will say like, okay, but for that scale of project, we'll have a crane in place anyway, and so that requirement, like, it's a very interesting but slightly theoretical discussion at this point, because I think, first of all, we do not have the luxury to sort of demolish everything that we have and build the reusable city 2.0. We really need to make sense of the materials that are there today. And I would say that it's, well, I'm a material seller, so I would obviously say that, but I think it's a responsibility of designers to find applications for already existing, already extracted materials in their designs today. But of course, yes, please use more nails and less glue, screws if you really have to, but nails are really, really nice for us. Those sort of things are, I think, you know, you could do a whole school just on that question, but by reusing within your own practice materials that have already served once, you'll quickly understand what not to do if you want to reuse materials.
There's some nice checklists as well. There's the Design for Deconstruction Standard, ISO 20807, has lovely checklists that can kind of guide you as you're starting out. But as you say, nothing beats trying to figure out the glues and the adhesives and removing them from the materials that you showed during the talk earlier. So is there any more questions at the moment from the floor? If you could raise your hand, just that lady there, please.
Hi. Dublin is, you say you're not going to work in any more demolition projects where there's going to be a rebuild afterwards?
Sorry, I'm having a hard time understanding it.
That you won't work on a project where something has to be demolished and then rebuilt in its place. Dublin is quite a low density city, so there's obviously a discussion about the sustainable use of land as well, to demolish something and then rebuild in a denser manner. Is that something else that you discuss in practice?
Okay, I think that's a fair point, and I mean we're using multiple criteria to decide what projects that we do, and indeed a building that is extremely low density, that is in an area that invites for higher density, would make a good exception on that. But what we are seeing right now is that basically inside commercial architecture is that skeletons in steel and concrete. I mean, the concrete is cheaper than water, as I said, well, than sparkling water. And so there's a form of laziness that we really want to oppose to. Most of the time, many sort of like ceiling height is a typical example. Like, oh, we would really like to reuse that building, but the ceilings are 2 centimeters too low. Well, if you work with a proper engineering company, I'm pretty sure that you can manage your techniques in another way, or maybe you'll have partially exposed ceilings and you deal with the acoustics in another way. Like if we would just stop being lazy about reusing many of these projects, then that would already go a long way, I think.
So I've got another question. We see robots and automation being used more and more in the construction industry to sort the materials, to look at the material properties. It has obvious carbon implications. And I was wondering what your thoughts are on that, if you've done any research in it, or how you feel about the continuing automation of the industry going forward.
Yeah, I mean, it's like, it's not something that we are ourselves heavily involved in. Like, I think, like for instance, if you would draw the parallel with a pharmaceutical company, you have those that are very creative and they discover new medicines, and then you have those that are sort of very corporate and they just manage on upscaling, on production, on going. We're more on the experimental thing, and I think that some of the ideas and some of the things that we do have a potential on a bigger scale, and at that point, it's basically out of our hands. We sort of need to show that it is feasible, and then others need to take it from there. That said, I think that within the field of design and innovation, there's a sort of a bias for public research money to go into very high-tech projects. Like universities, they'll love to buy a new scanner or a new 3D printer and so on and so on. And these are actually very expensive if you compare it to something that is as simple as making a technical documentation specification sheet for a few materials. There is an unbalance in the amount of money and resources that goes to the high tech at the moment, and I think what I would call, for lack of a better word, like the social design, like what sort of processes do you need to put up? Well, you don't get big machines to show off to your funders, so it's much harder to do, and I think it's more urgent. The low-hanging fruit is really on that side, in my perspective.
I know there's a hand there in the middle. And this one over there as well, yeah.
We'll take you afterwards.
Hello, my name is Johannes. I'm from Vienna, studying architecture in the Academy of Fine Arts. Very nice to be in Ireland. And at my office, I was a gardener, a social worker before I studied architecture. And we have a cooperation with Baukarussell and Thomas Rom, and we focus because at this point about the concrete and how much you need to pay a person, and then you're of course much more expensive. That is just the case if you need to pay the person. And I think that my proposal is not slave labor, but there are many social projects who give jobs to long-term unemployed people or young people who don't find vocational, I think, education in the private sector. And they all need a lot of work. So maybe there needs to be a second map in where are the materials, where are the workforce who needs to have training in that kind of field. And yeah, I think that this is like the second component is like the materiality, and on the other hand, are like the hands, where are the hands available to do the work? Sorry, that was another question.
I mean, does the salvage industry offer job training opportunities? Yes, it does. Just like the restaurant business, just like any sort of business, right? They're absolutely there. Is picking up concrete pavers from a road for 60 days in a row a job training? No, it's not. No, we have to be careful that job training programs are used for training people to give them something that they can actually move forward on. Because if you are highly trained in stacking things on pallets, well, the only job that exists within that industry is taken by the training institute. So I think actually training needs to be something that, well, it's a dual thing, because you could also say like it can be former prisoners. It can be like we work with many social organizations that try to put people on the right track, but to consider them as cheap labor, as I'm sure we agree, is a problematic thing to do. Like, perhaps to answer your question about robotics, perhaps stacking those pavers perhaps that is a job for like, it would still be too expensive. Like, the price of concrete does not justify such an investment in such a machine at this point. I think, sorry, I'm taking a long time to answer your question, but I think my basic point is that we are not paying the right price for many materials. And so our economy is basically biased towards two materials that are among the most polluting that mankind makes in such quantities. And so on a structural level, we need to really deal with the economic question. And then once that is dealt, we can think about labor organization and so on. And there will certainly be opportunities as much for robotics as for human beings. But the problem is really that what we are trying to do at Rotor DC is actually almost the opposite of what our economy was designed to do. And that is something of a frustrating situation. Yeah, we had a...
Yeah, hi, Justin Hunter. I'm just curious about the relationship between using new and using reused. And if you think of it in the reuse cycle, there's demounting, there's storage, there's transport, there's communication about the availability and matching up with vendors, with sellers and so on. Is there a view on the relationship of the carbon footprint between using new versus using reused?
Okay, so of course we cannot do an LCA on every door that passes through our shops, so we'll do it on like recurrent things in typical case studies. And every time that we do it, the results are just incredible. Like, for instance, the reused ceramic tiles were at 10% of the impact of the equivalent new product. And actually that LCA basically pointed out that if we changed our packaging system, we would be even better than that, because many of it was just the plastic straps and the types of crates that we were using. Actually, even like the staples in the crates were actually more than a problem than anything else. Like a simplified way of thinking about it, like, for instance, if you imagine that we are in Brussels and there is a proposal to reuse these wooden beams and cut them into slabs, right? What you do is you make two columns, and you make a typical product and the salvaged one. And then things were that are the equivalent, you can basically strike them through. Like our wood needs to be cut, well, a tree also needs to be cut. There's no reason to assume that our sawmill would be using much more electricity to make their blades spin than the other one, so we just get rid of that. And so in the end, the things that you're really winning on is less processing and keeping the materials local. Most of the time, if you will send them as far away as new products are being sent out, you lose the advantage quite quickly, because a lot of the carbon in our materials is actually the transport cost. Now, for things that are baked, like bricks and ceramics and so on, there's a lot of like literal gray energy also that goes into that. But many other products, it's on the kilometers that we make a huge difference. So we try to source our materials locally, and we kind of like to think that if we stick within 100 and 200 kilometers around Brussels, which is very local for building materials, most of the time we don't really need, I mean, the results are so obvious after striking through the equivalent costs. Most of the time we won't need a detailed LCA. You know, I mean, every time we do this kind of tests, the results are incredible. Like for instance, the first building that I showed you, where we sold the materials that while we were demounting them, right? Then we had a student following up in environmental management, following up that pilot scheme, and so he made a sort of a CO2 equivalent score for that thing, and we basically understood that operation in just a few months of time was the equivalent carbon savings of the entire new solar roof that they were putting on this newly renovated building, and so it's actually quite crazy. It's such incredible large amounts of carbon that you can save in this way, that it's quite incredible that it's not happening more, actually. I think it might have to do with how these scores are measured and calculated, like BREEAM and so on are. But that I guess is more your domain. Like, why doesn't it appear better in scores?
I don't know. I think we have a long way to go here in Ireland. Like, if you look at the circularity metrics internationally, you're looking at 11% circularity is average across Europe. The Netherlands are doing fantastically. They've got about 24% circularity, and Ireland has a long, long way to go. It's got about 2% circularity at the moment. And I think architects, designers, engineers, we're the coalface. It's up to us to act, really. I had a
Many others have worked there. This mapping has not been done before, and so it means that after 6 months, all of the students in our class are basically, they have spent more time visiting sellers of second-hand building materials than anybody else in the country, you know? And so they instantly become the experts, and that is quite, I mean, if you would want to be the expert in energy efficiency, you can do a PhD for like, you can do 3 PhDs, spend 15 years, and you probably still know, this field is so empty at the moment that you're like just barely scratching the surface, and you already know much more than what many people are doing. So the social skills in this first thing are really, like, to give you an example, we launched Opalis in Germany like 3 weeks ago. they got our students send out an email saying we want to visit companies like this is the profile we're looking for, and so on. They got a call from a federation of entrepreneurs, and so after 3 weeks of our class, they were on stage trying to explain to the entrepreneurs what's this thing with reuse. So it's pretty exciting how the whole thing is turning around, and a lot is going to happen. Like for me, now it's a matter of like distributing this task. We cannot possibly be in charge of every demolition site across the world. So ideas need to circulate. The examples need to sort of like. None of this is rocket science, really. Like all of you can basically write a proper demolition tender that has more than 2 criteria in it. It's really not that hard, and so we need to spread that, I think.
Excellent. Yeah, it's absolutely systemic change. It's every actor along the supply chain, along the life cycle. I think in carbon budgets will probably be a game changer. So we've gone over time, so we're probably going to end this. There doesn't need to be any more hands raised. So I'm going to thank you so much for your attention, your participation this evening. Thanks so much to Maarten for a truly inspiring call to action, I think, for the Irish architecture and design community. I'd like to thank Natalie Wiedek and the Irish Architecture Foundation for curating the event this evening, and also my colleagues in Arup, Rory McGowan and Claire O'Loughlin for all their organisational work that went into tonight. I'd like to ask you to come to the same time, same place next week to listen to Jess Boyce's lecture, which will be extremely engaging. And thank you so much for your kind attention this evening.